everyone! For this video, the topic to be discussed is Andresito Acuña's book entitled Philosophical Analysis, Advanced Techniques for Critical Thinking.
Specifically, Modules 2 to 7 of Unit 3, which is Analysis of Deductive Argument.
Some of you guys, blockmates, could already have an idea regarding this concept, especially those who took on the subject Gen Math during senior high school.
But don't look at it as something easy, as Andresito Acuña, the author himself, stated that this unit is the most difficult among all units from this book.
But before all that, let us introduce ourselves first. I am Toni Samala, together with
Evonne Caliuag,
and we will be your guide for this unit. And for the flow of our topics, Modules 2 to 4 will be discussed by me,
and I will be discussing for Modules 5 to 7.
Now, let us move on to Module 2. First, let us define compound statements. As you can see in the presentation, first, compound statements are one of the finest logical classifications of statements. They also belong to the analytic variety and is part of the historical development of formal deductive logic. Now, I know that you might get flabbergasted or confused with the words that I am saying, but just sit tight as I discuss this module part by part. In this module, you will learn how to isolate the logical form from the content of compound statements by the simple technique of representing them. Without these foundational skills, you will never learn how to analyze a deductive argument, which is the main matter of Unit 3. So, parang the first part of this module will help you na slowly mabuild yung knowledge para maintindihan mo kung paano mag-analyze ng deductive arguments para sa Module 7. Representing statements. Ayan, you must learn how to represent statements. Paano? It is by isolating the logical structure of the statement from its content. Again, isa-separate mo yung logical structure from the content ng isang statement para makarepresent ka ng statement. So, bakit mo ba kailangan mag-represent? Kailangan mo ito para makagawa ka ng truth tables. And with truth tables, you can reveal the logical form of a compound statement. But before we proceed further, you must understand and remember that logic is not interested in studying or analyzing the content of the argument, but only its logical form. Move on na tayo to convention for representing statements and logical constants. For A, you will use a single capital letter to represent a simple statement. By definition, ang simple statement ay walang connecting words. And apat lang ang connecting words sa FDL or sa formal deductive logic. And these are what is shown sa table under letter B. Moving on naman to the table. The table shows the connecting words, which are also known as logical constants. First, the shaded dot symbol, it is used to represent the word and at ang technical term for this is conjunction. Next is the symbol V that represents the connecting word either or, and it has a technical term alternation. For the third is the arrow symbol which represents the connecting phrase if then. The technical term for this is conditional. Lastly is the symbol yung 3 lines. It represents the connecting phrase if and only if, which is for the technical term biconditional. Remember na yung conventional symbols for representing the 4 logical constants have specialized uses. Kasi for symbolic logic, kaya kailangan ma-memorize nyo sila so that you could proceed with ease sa next parts of our report. Remember that in representing simple statements, gumagamit tayo ng capital letters and simple statements ay walang connecting words. Kahit gaano kahaba, basta walang connecting word, simple statement yan. Consider the statement on your screens. Brothers are male siblings. It is a simple statement and can be represented by any of the 26 letters sa alphabet. For other examples na nasa screen ninyo, such as the statement saying that a triangle has 3 sides with 3 angles, it can also be represented by any letter, and I chose the letter T. The same goes with the statement, bats are mammals, which is represented by letter B. If napansin ninyo, upon representing simple statements, nawawala na yung content niya, which kailangan natin lalo na when talking about compound statements, so that mas madali ma-reveal yung logical structure ng isang statement. Okay, so we can say na the statement Aristotle is a philosopher and represent natin yun with the letter A. Tapos, may another simple statement saying na Plato is a philosopher and na-represent yung statement na to with the letter P. So, we can conjunct these 2 simple statements and make it into one compound statement that says Aristotle is a philosopher and Plato is a philosopher. Or, a shorter version nito na Plato and Aristotle are philosophers. Remember, we use the connecting word and if you look back into the table, it uses the symbol of the shaded circle. So this compound statement will be represented by a shaded circle P, as shown on your screens. Again, I will just repeat that in representing statements, we let go or we forget about the content of the statement, as we only need the logical structure. Upon representing the statement and getting its logical structure, we can now focus on the logical form. And a logical form is a conjunction. Conjunction dahil nga we use the connecting word and. Now, let us represent compound statements in the alternation form. So, same given lang. Aristotle is a philosopher, represented by the capital letter A, and the second statement is Plato is a philosopher, represented by the capital letter P. Now, we have learned that connecting word phrase for alternation is either followed by or. We can now read the compound as either Aristotle is a philosopher or Plato is a philosopher. Or, for the shortened version, Aristotle or Plato is a philosopher. Moving on to the conditional using the same two simple statements we used earlier. We know that conditional compound statements are connected by the words if and then. So our statement would be if Aristotle is a philosopher, then Plato is a philosopher. Lastly, let's take a look at the same example but now with the biconditional connecting. We know that if it is biconditional, the statement uses the phrase if and only if. Now, the biconditional statement reads as Aristotle is a philosopher if and only if Plato is a philosopher. Now, alam mo na kung paano nagre-represent ng compound statements using their logical structure, and these are conjunction, alternation, conditional, and biconditional. Uulitin ko lang, you should remember that by representing compound statements, you isolate the logical structure from the actual content of the compound statement. Let me now introduce you to negation. Sounds difficult, but fortunately it is simple to use and is a powerful tool in logic. Let's say that you represent a simple statement using the letter S. To negate this, you will simply put a tiled symbol like tiled S, and this reads as not S. The same goes with other simple statements. For example, simple statement T. The negation for this is tiled T, which reads as not T. So yes, it is not only simple statements that can be negated. We can also negate compound statements by simply putting the tiled symbol. And as shown on your screen, for conjunction, it reads as it is not the case that T and S. For alternation, it is not the case that T or S. For conditional, it reads that it is not the case that T, then S. Lastly, for biconditional, the negation reads as it is not the case that T if and only if S. Now, if mapapansin ninyo, baka nagiging redundant na ang it is not the case. You can replace it naman with other phrases such as it is false that or kaya naman it is not true that. Now, if you have noticed with the examples from the previous slide, the parenthesis marks the scope of the domain. Therefore, you can use negation in other ways such as tiled T, ROS. And this reads as not T, then S. Since ang T lang naman ang nakanegate and not the whole compound statement. Other examples could be tiled T, arrow tiled S, which reads as if not T, then not S. Pwede rin maglagay uli ng parenthesis like with the third example on your screens, and that reads as, it is not true that if not T, then not S. Mukhang mahirap, but with enough practice and patience, maiintindihan. Summarizing all that you have learned from this module, it is the four logical constants. Yung symbols used for each, the connecting phrases, the technical terms, and how to use them in representing compound statements. Aside from this, you have also learned about the concept of negation. Lastly, you must remember that these concepts are unavoidable and must be memorized, as the study of FDL or formal deductive logic cannot be done without these. Whew, that was a long ride already. But now let us move on to Module 3 for truth values and compound statements. This module will provide you with the basic techniques for determining the truth values of compound statements. These techniques are very important because without them, hindi mo maiintindihan or hindi mo rin ma-apply ang other techniques which are even more complicated. So for this module, you will learn about the concept of validity and invalidity in deductive arguments, while also recalling some core lessons from previous units. In the first module of Unit 2, as you may recall, you were introduced to the three principles governing the truth values of statements, and these are the principle of identity, the principle of excluded middle, and the principle of non-contradiction. So first is the principle of identity. For example, you know that puppies are young dogs, and this could be represented by the capital letter P. Now, if P is true, then P is true. Therefore, the principle of identity states that statement P implies itself, and can be represented as if P, then P, or can also be represented as if not P, then not P. And this is an example of tautology. So I have mentioned the concept of tautology. Let us now define it further. Tautology means that the truth value of a statement is retained indefinitely over time, which also means that the truth values are more or less stable over time. And like what we have discussed from the previous slide, it is guaranteed by the principle of identity. Next is the principle of excluded middle, which guarantees that the truth value of any statement like P is either true or false only, and this is represented by P V tilde P. This shows that if you know that P is not true, then you also know that the negation P is false. You know this because following the principle of identity, you know that the truth of P is stable over time so that it can only be true or false, and this is called the logicians as truth function relation. Since it was mentioned that P can either be true or false only, and according to logicians, the technical name for this relationship is the truth function relation, which simply states that P and not P are truth functionally related. The negation sign before a statement does not necessarily mean that the statement is automatically false. It just means that it is the negation or the opposite of P. This also implies that P, V, tilde P, or P, or not P is a form of tautology. The principle of non-contradiction prevents you from assigning two truth values to a statement at the same time and in the same respect. Ibig sabihin nito, P cannot be both true and false at the same time. Either true lang si P or false lang siya. So, applying to statements, puppies cannot both be young and old. It is represented by the symbols on your screens, which reads as, it is not the case that P and not P. The principle stated from the previous slide implies that the symbols on your screen, which reads as P and not P, is always false and is self-contradictory. It also implies that negation of P and not P is always true, therefore it is a tautology. The previous module has introduced you to the concept of negation, and now this concept will be used in much more complicated applications. Now, look at the table on your screens. This is a representation of the truth values of P and is negation. This table also reflects the truth function relation, which we have discussed a while ago, which states that if P is true, then negation of it is false, and if P is false, then the negation of it is true. Moving on to the concept of double negation. We know that P cannot be true and false at the same time, as this would violate the principle of non-contradiction. However, the case of double negation is plausible. As seen on your screens, the symbol for double negation is tilde P. While when it is negated 3 times, it is denied, but when it is negated 4 times, it is again affirmed. Affirmed when true and denied when false. Consider the table on your screens as a table for conjunction. The first 2 vertical columns P and Q contain all the possible substitution instances of the truth values of the 2 statements P and Q. If you have noticed, true ang truth value if nag-join ang dalawang true, and once na may isang false sa P or Q, automatic na false na yung truth value niya sa last vertical column. If one premise is false, then the whole premise set is false. An alternation is false only when both alternants are false. This means that the minimum requirement in formulating a true alternation is at least one of the alternants must be true. It will not matter even if one is false. In conditional truth table, the only requirement for a set to be false is that P, or the first premise, must be true, and Q, the second premise, must be false. Let us now discuss the logical form of a deductive argument. Most logicians will agree that the logical form of all deductive arguments is logically isomorphic with the logical form of the conditional statement. Ibig sabihin ng isomorphic is that it is the same. Now, take a look at the shaded region in the presentation and compare it to the situation with the conditional truth table that we have discussed. They are the same, that the first must be true and the second must be false in order for the argument to be false, or in this case, it is called invalid. This means that the premise set of a deductive argument is joined to its conclusion by the conditional connected. Now, for biconditional, the truth table for it is shown on your screens. If you have noticed from the shaded regions, the requirement for the argument in biconditional truth tables for it to be true is that both P and Q must be true. Another way for it to be true is when both P and Q are false. You must recall from the previous module that to negate a statement, it must use the tilde symbol. You must also recall that the parenthesis sets what it negates. So for the example on your screen, the tilde negates the whole statement representation of P and Q. The same goes if we take a look at other logical constants. It does not matter what the logical constant is as long as if it is a negation. Then it is the opposite. Take a look at the negation of alternation. When one without negation is true, the one with the negation is false, and vice versa. The same goes with biconditional and conditional. Let us now summarize what you have learned in Module 3 using this table. You have learned and recalled the concepts of the three principles, namely principle of identity, principle of excluded middle, and the principle of non-contradiction. You have also learned how to represent these concepts using the symbols shown on the second column shown on your screens, and you have also learned that all of these principles are forms of tautology, meaning that they are always true. Aside from these, you have also learned about the truth tables of conjunction, alternation, conditional, and biconditional, and how to use these concepts on negation and double negation. Lastly, it was also emphasized in this module that the logical form of deductive argument is logically isomorphic or the same with the truth table of conditional. That was quite long, but we have just finished two modules. Modules 2 and 3. We now have to move on to Module 4. Before proceeding to the next parts of the video, make sure that you have understood and familiarized yourself with the topics from the previous parts of our presentation. This module will introduce you to the basic rudiments of representing arguments in order to isolate the logical structure of the argument from its content. You have to learn this because if hindi mo ito alam, hindi mo makakayang mag-separate ng logical structure from the content of the argument. And if hindi mo ito kayang gawin, you would not be able to judge whether a statement is valid or not. Let us define what you now see on your screens. 1 is a compound statement, while 2 is a premise and 3 is the conclusion. Both 2 and 3 are simple statements. Now, we can represent premise 1 with the letters R and A from represent an argument. And for the conclusion, we can use the 3 dots, which is the logical convention for conclusions. With all that was stated from the previous slide, we now arrive to this vertical representation of the argument as shown on your screens. The first, which was a compound statement, is now represented using R, arrow A. Arrow was used because the original statement said if and then. Now, for part 2, it is represented by R because it is the same simple statement from one of the simple statements from the compound at part 1. And for part 3, it is represented by 3 dots, meaning it is a conclusion, and the capital letter A because it is one of the simple statements from the compound statement from part 1. From the given statements, we are able to arrive with the vertical representation. In part 1, it is a compound statement using the conditional symbol, and for part 2, it is the simple statement from one of the simple statements in the compound from part 1. That's why it is represented by S. And for part 3, it is represented by the 3 dots because it is a conclusion, and the capital letter R because it is the same simple statement from one of the simple statements from part 1. If you examine the two representations from the examples that we have studied, they have a similar logical structure where premise 1 states a conditional, meaning may dalawang statement na gumagamit ng if, then as connecting phrase. Premise 2 affirms the antecedent of the conditional. To understand this, let us take a closer look at the if R then A example. The second part of this example affirms or states that R is indeed a fact. In addition to this, R is the antecedent from part 1. Antecedent meaning the letter that came before the arrow of the conditional representation. Next, for the third part, it concludes R, which is deducted from two premises. Let us take a closer look again at example if R then A. From part 1, we have stated that R is the antecedent and A is the consequent. With this, it is logical that A is the conclusion for part 3. Again, we will be taking a look at the two examples. If you have noticed, this logical structure is always valid, and the name for this logical structure is modus ponens. It is valid because if you construct the truth table of the argument, it will not have a case where the premise set is true and the conclusion is false. Now, since we have talked about validity, let us tackle on invalidity. An invalid argument form is shown on your screens together with its invalid representation. This type of fallacy is called affirming the consequent. It is invalid because, as stated from the name, the second premise affirms R when R should be the consequent or the conclusion. Therefore, it is called affirming the consequent. This logical structure will always be invalid, as if you construct the truth table of this argument, you will have a case where the premise set is true and the conclusion is false. Now, let's take a closer look at another type of valid argument form. The structure shown on your screen is the structure of addition. Remember that an argument that shows the structure of addition and modus ponens is valid whatever its content is. There is no case in which the premise set is true and the conclusion is false. The logical structures that I have shown you, like the addition and modus ponens, are not the only forms of valid arguments. There are also other forms that differ but can still be considered as a valid argument. You have to take note that in order for an argument to be considered valid, it must be that there is no case in which the premise set is true and the conclusion is false. This is why we need to represent statements into symbols so that we can see and determine its truth values, which will further be explained and tackled in Module 7. Formal deductive logic has another convention for representing the structures of an argument. Take a look at your screens. This is one of the examples that we used earlier. Now that is the vertical representation, there can also be a horizontal representation. This is the horizontal representation where premise set 1 and 2 are joined by a conjunction. Ayan, as you can see, 1 yung naka-parenthesis which is if R then A, and then the second premise is connected to this using ang symbol para sa conjunction which is the shaded circle. And this connects the second premise which is R. If you can also remember, formal deductive logic is similar or isomorphic to conditional statements. So, the premises are connected to the conclusion using the symbol for conditional, which is the arrow. Lastly, before we end this module, you have to remember and always take in mind that the conditional statement is false only when the antecedent is true and the consequent is false. You should also understand that there is no degree in validity. Either a set is valid or it is invalid.
Thank you, Toni, for discussing modules 2, 3, and 4. Let us now move on to the 5th module entitled Basic Deductive Argument Forms. In this module, you will be able to differentiate the basic types of valid and invalid argument forms and learn how to formulate each. Our discussion for Module 5 would be divided into 2 parts: types of valid argument forms and types of invalid argument forms. Let us now begin with the first half. We knew from the previous discussion that an argument is valid if there is no specific case where a premise set is true and yung conclusion naman is false. The first basic type of a valid argument form is called conjunction, wherein you conjoin two true statements. If two true statements are not related, you can still conjoin them as long as they're both true. Kunyari, may dalawang statements ka na alam mo na totoo. Pwede mo silang i-conjoin to preserve the truth value of the conjunction. The structure of the argument is as follows. First, A, second, B, and for our conclusion, therefore, A and B. Remember na yung malaking dot between A and B, binabasa siya as and. Pwede tayong makaform ng conjunction basta alam natin na both statements ay totoo or factual. Next type of valid argument form is simplification. If the conjunction of two truth statements is a valid argument, then yung pagsiseparate sa conjuncts of two truth statements is also valid. Sa pagsiseparate nga ng conjuncts, nape-preserve din yung truth value. In short, sa simplification, pwede tayong mag-conclude ng isang statement mula sa bagong statement na nabigay natin. The structure of simplification argument can be first, A and B, second, therefore A. Or it can be first A and B, or therefore B. All arguments with this argument structure na ganito, valid lahat. In conjunction, we can conjoin two true statements. Sa simplification naman, nakakapag-conclude nga tayo ng isang statement mula dun sa conjunction. Moving on to the third type, suppose you know that two statements are true. Then, mula dun sa two true statements, pwede makagawa ng alternation. Remember, if you know two statements to be true, you are entitled to form an alternation at conjunction. Yung difference lang ay yung words na ginagamit sa conclusion. And sa alternation, pwedeng yung isang statement ay false basta one of the statements is true. The argument structure of alternation is as follows. First, A, second, B, and for our conclusion, therefore, either A or B. Remember sa discussion ni Toni na yung letter V dyan ay nagsastand sa either or. Kaya nagiging therefore, either A or B. Uulitin ko lang na we can still form an alternation kahit false yung isang statement as long as one of the statement is true and hindi sila parehong false. The fourth type is adding an alternative. Remember that in alternation, it is acceptable to have one untrue or false statement as long as the other statement is true. So you can form an alternation by adding one true or false statement sa isa pang statement. Nagiging false lang siya if both statements are false. Yung tawag sa valid argument na yun ay adding an alternative. The argument structure for this is first A, and for our conclusion, therefore, either A or not B. So, nalaman nga natin sa discussion ni Toni na yung symbol na makikita in between V and B, ang basa doon ay not, inferring na false yung statement. Meaning na yung inad na alternate ay false. Lastly, One type of a valid argument form is disjunctive syllogism. Detaching an alternative is valid when we know that one of the alternants is true and the other is false. It will be false if both statements ay true or parehong false. This is called disjunctive syllogism. In short, sinasabi lang dito na madedetach or pwede nating tanggalin yung isang alternant na alam nating false. Hindi pwedeng parehas na alternant ay true at false kasi hindi sila pwedeng paghiwalayin dahil according to the valid argument principle, the premise is true and the conclusion cannot be false. The argument structure for disjunctive syllogism is as follows. First, either A or B. Second, not B. And for our conclusion, therefore, A. Or it can be the other way around. First, either A or B. Second, not A. So sa conclusion, therefore, B. So that's for our valid argument forms. Let us now proceed to the other half, the types of invalid argument forms. Let us first define an invalid argument form. Going back, valid argument form is where the premise and conclusion is both true. On the other hand, sa invalid argument form, it is an argument where the premise set is true and the conclusion is false. The first type is subtracting an alternative. Recalling the previous type, an alternation is true even if one of the alternants is false. This is the reason why we cannot infer or conclude any of the statements as true since baka yun pala yung false na statement. Ganito yung tinatawag na subtracting an alternative, wherein we may encounter a case where the premise set is true and the conclusion is false. The invalid argument structure is as follows. First, either A or B. Second, therefore A. Or it can be first, either A or B. Second, therefore B. Both forms are invalid kasi baka nga yung makonclude natin, yun pala yung false. Moving on, the second type of an invalid argument form is denying an alternative. If you know that a statement is true, you can conclude or infer na yung isa pang statement ay false because alternation is true kahit both alternants are true or kahit isa lang sa kanila yung true. In short, denying an alternative is when both statements could be true or one statement is true and the other is false as long as hindi sila parehong false. The structure for this invalid argument is as follows. First, either A or B. Second, A. And for our conclusion, therefore not B. Or yung structure pwede rin maging first, either A or B. Second, B. And for our conclusion, therefore not A. This argument becomes invalid since we inferred from the second or the Roman numeral number 2 na yung isang statement ay totoo. Invalid argument siya kasi pwedeng both of them are true or maling statement yung nakuha natin since sabi nga sa alternation, pwedeng totoo yung isang statement and pwede rin false yung isa at magiging valid pa rin kahit ganun. Let us now move on to the last type of an invalid argument. Adding a statement to one true conjunct is an invalid argument called adding a conjunct. The statement na ina-add mo may be false, and if you can remember, according sa conjunctions, it must be composed of two true statements. The structure for this invalid argument is as follows. First, A. Second, therefore, A and B. Invalid to kasi baka yung na-add mo na conjunct or yung B ay false and hindi na siya mag-a-adhere dun sa rule ng conjunctions that both statements or conjunct must be true. So, magiging invalid na yung argument no. So now, we are done discussing Module 5 or the basic deductive argument forms. Let us now proceed to Module 6 entitled Complex Arguments Forms. This module will provide you with a technique for discriminating the more complicated arguments dealing with conditionals. These are the types of arguments you are likely to encounter when you read logic book. To start, let us first differentiate modus ponens from affirming the consequent. Modus ponens is a valid argument form since the truth of the premise guarantees the truth of the conclusion. The argument structure for this is as shown on screen. First, if R, then L. Second, R, and for our conclusion, therefore, L. Moving on, we knew from the previous module that affirming the consequent is an invalid argument form because the truth of the premise does not guarantee the truth of the conclusion. The structure for this invalid argument is as follows. First, if R, then L. Second, L. And lastly, therefore, R. Comparing the two, sa affirming the consequent, hindi nagaguarantee ng truth ng premise yung truth ng conclusion. Their difference is that sa modus ponens, ang ina-affirm or vine-verify yung antecedent. Meanwhile, ina-affirm naman yung consequent, obviously, sa affirming the consequent. Valid argument form yung modus ponens as mentioned, since the truth of the premise, sinisigurado nun yung truth ng conclusion. Furthermore, affirming the consequent is an invalid argument form since the truth of the premise does not guarantee the truth of the conclusion. Moving on, we will further differentiate modus tollens from denying the antecedent. Modus tollens is a mode of reasoning from a hypothetical proposition according to which if the consequent is denied, the antecedent is also denied. According to formal logicians, the valid form is when you deny the consequent, you will have the valid argument of modus tollens. The structure of this deductive argument is first, if R, then L. Second, not L. And for the conclusion, therefore, not R. We deny the antecedent and the consequent since na-mention sa second and third statement na not L and therefore not R. Moving on, when you affirm the consequent and then deny the antecedent, we are creating an invalid argument form named denying the antecedent. The structure of this is as follows. First, if R, then L. Second, not R. Therefore, not L. Further digging into their similarities and differences, modus tollens denies both antecedent and consequent. However, in denying the antecedent from its name, we affirm the consequent and deny the antecedent. Next, we have detaching the consequent. It is an invalid argument form wherein you cannot infer the consequent because the antecedent and consequent of a conjunction could be false, yet the conclusion can still be true. It follows a structure as follows. First, if R, then L. Therefore, L. Moreover, we have hypothetical syllogism. It is one that starts from several judgments based on hypotheses and ends up drawing a valid conclusion when relating them to each other. This states that the consequent of the first premise is the antecedent of the second premise. It follows a structure as shown on screen. First, if R, then L. Second, if L, then C. For the conclusion, therefore, R, then C. We can observe that the consequent of the first premise is the antecedent of the second premise. Further clarify, we have fallacy of misplaced middle. This is often confused with hypothetical syllogism since the fallacy of misplaced middle is where the statement that relates the two other elements is misplaced, forming an invalid conclusion. The structure of this valid argument is as follows. First, if R, then L. Second, if C, then L. Third, therefore, R, then C. This happens when the common element is the consequent of both premise. Moving forward, we will now differentiate constructive dilemma from pseudo-dilemma 1. Constructive dilemma has a conjunction of two conditionals with the affirmation of at least one of their antecedents. This implies that at least one of the consequent is true. The logical form of constructive dilemma is a combination of two modus ponens. Its structure is as follows. First, either R or L. Second, if R, then C. Third, if L, then C. For our conclusion, therefore, either D or C. Pseudo-dilemma 1, on the other hand, is an invalid fallacious form of dilemma that denies the antecedent. This fallacy denies the antecedent of premise 1 and 2. So, hindi tayo makakapag-conclude nung denial ng both consequences. The argument structure for this is as shown on screen. First, if R, then D. Second, if L, then C. Third, either not R or not L. Lastly, therefore, either not D or not C. Next, we would further differentiate destructive dilemma and pseudo-dilemma 2. Destructive dilemma is the negative version ng constructive dilemma as mentioned kanina. Essentially, destructive dilemma passes the negative statements of the disjunction through two conditional statements. If yung dalawang conditionals na yun ay true, but one of their consequent is false, then one of their antecedents has to be false. The argument structure of destructive dilemma is a combination of two modus tollens. Diba sinabi nga kanina sa constructive dilemma, yung argument structure nun is the combination of two modus ponens. The argument structure of this form is as follows. First, either not D or not C. Second, if R, then D. Third, if L, then C. Lastly, for our conclusion, therefore, either not R or not L. Pseudo-dilemma 2, on the other hand, is an invalid, fallacious form of dilemma that affirms the consequent. So, hindi niya pwedeng i-affirm yung antecedent as mentioned. The structure for this is as follows. First, either D or C. Second, if R, then L. And third, if L, then C. In conclusion, therefore, either R or L. It affirms the consequent of premise 2 and 3, so hindi niya pwede i-affirm yung antecedent as mentioned dun sa description ng pseudo-dilemma 2. Lastly, before we move on to Module 7, we must remember the norm. Either affirm the antecedent or deny the consequent of a conditional and you get valid argument all the time. We will now move on to the last module, Module 7, or the truth table method. In order to conclusively demonstrate that the argument form is valid, one method can be used is the truth table method. In this module, we will apply all the skills, concepts, and principles we have learned in order to be able to perform the very complicated task of determining the validity or the invalidity of any argument form in terms of the truth table method. There are several steps to efficiently use the method. First, you have to represent the argument in horizontal form. Let's use this vertical structure, a modus ponens, as an example as shown on your screen. First, if R, then L. Second, L. And for our conclusion, therefore, L. Yung vertical structure na to, gagawin natin siyang horizontal structure. Kapag kinonvert natin yung vertical into horizontal, ito yung magiging result as shown on your screen. The second step is to count the number of simple statements in the argument. We have 2, yung R tsaka yung L. Therefore, we need to construct a table for all the possible substitution instances of the truth values of R and L. The table is as follows. Makikita natin dito na may 2 columns. Sa first row, may instances na true sila pareho. Meron din naman na true si R pero false si L. Following the example, following yung gist niya, may instances na false si R pero true si L. At lastly, may instances din na both false sila pareho. Additionally, if you have 3 statements in your argument, you will have the following table with 8 rows. These are all the possible substitution instances of the truth values of an argument structure. Dadagdag lahat to kapag dumadami yung statement. Kunyari, kapag 4 yung statement, mayroong 16 rows. Kapag 5 naman, may 32 rows and so on. Lastly, after makomplete yung table of substitution, we have to assign the truth values to the statements in argument structure. Makikita natin yung table dito sa screen. Please note that there's no horizontal in which the premise set is true and the conclusion is false. The argument form is valid in all possible substitution of the truth value of the statements of the argument. Makikita natin na yung premise set natin ay true, so yung conclusion natin ay true din. Wala tayong makikita na yung conclusion ay false, kaya lahat ng argument na to ay valid. Moving on, para mas maintindihan pa natin lalo, let us consider the invalid form of affirming the consequent as an example. This is a case where the premise set is true and the conclusion makes the argument form invalid. Presented on your screen is the logical structure in vertical form. As shown, first, if R, then L. Second, L. And for our conclusion, therefore, R. Next, we represent the logical structure argument in horizontal form as shown on your screen. Second, we construct the table of substitution. We only have 2 statements, statement R and statement L. Makikita natin dito yung 2 columns nga. Sa first row, may instances na true sila pareho. Meron din na true yung R pero false si L. Following yung example, may instances na false si R pero true si L. At lastly, meron din naman na both silang false. Then third, we assign the truth values to the argument as presented. Makikita natin na may isang invalid sa table since may premises tayo na true pero yung conclusion natin ay false. Remember, sabi nga din sa norm, an argument is only valid kapag yung conclusion ay true at yung premise set ay either true or false. So kahit yung premise set, ulitin ko lang, ay true or false, basta dapat yung conclusion ay true, valid yung argument. So, invalid yung argument na to kasi yung conclusion nga natin na makikita sa table ay false. Let us now move on to the falsification method, wherein it is a shortcut method of using the truth table in order to determine whether an argument form is valid or invalid. This method is needed when dealing with argument forms with 3 or more statements. Moreover, this method capitalizes on this by simply attempting to falsify the conclusion while demonstrating that the premise set is true. For example, itong naka-horizontal na logical structure as shown on your screen. Ayan. So first step is you need to falsify the conclusion while retaining the truth of the premise set. Yung nasa premise set is itong mga nasa bracket. Then yung conclusion naman is yung after ng arrow. So sinasabi nga natin, retain the truth of the premises. Therefore, i-assign natin na true yung sa baba ng premise set and false naman yung doon sa conclusion. Second, begin your analysis from the conclusion. If either P or R is false, this means that both P and R are also false. So ayan, kung yung premise set is true, yung mga nasa bracket, then both true sila as labeled on the diagram flash on your screen. Kung both P and R ay false sa conclusion, then P and R is also false in the premise. Now, we have a row where the premise is true and the conclusion is false. Kasi nga, kung false yung P and R, same value should be assigned to the P and R sa premise set. And kung yung P and R ay false sa conclusion, dapat sa premise set din, same value or false din sila lahat. Then, we are left dito sa Q na true natin. Notice that whatever the value of Q, either true or false, we now have a row where the premise is true and the conclusion is false. The argument therefore is invalid. Now, let us consider the hypothetical syllogism argument as follows. The first step is to falsify the conclusion while retaining the truth of the premise set. So, i-assign natin yung true sa premise set or yung mga nasa bracket and false sa conclusion or yung mga nandun after ng arrow. Next, we should analyze the conclusion. If our conclusion na if R then C is false, this means that R is true and C is false. Ayan yung mga R sa example. Lalagyan natin ng T stands for true and yung mga C naman ay F or false. Third, note that whatever value we assign to L, we cannot retain the truth of the premise while maintaining the falsehood of the conclusion. If the premise set is true, then both conditionals are also true. This means that the argument could not be falsified and we might conclude that the argument form therefore is valid. Meron naman tayong concept gaya ng word of caution. If hindi tayo nag-succeed na mag-falsify ng argument, hindi naman meaning nun valid na siya agad. There are cases where a false conclusion offers other combination ng truth values. In such a case, we must eliminate possible falsifying rows in a systematic way. Ito yung isang way para masiguro na invalid or valid talaga siya. Let's use this example for instance. First, falsify the conclusion and retain the truth of the premise. Note that if our conclusion is false, there are 3 possible combinations of the truth value. Matatandaan natin yung table na ginagawa kanina and as displayed below the conclusion, ito yung iba pang possible combinations ng truth values. Second step, assign the truth values of R and C in the first row. Since inassign nga na yung R is true and yung mga C is false, nagiging ganito rin yung example natin. And third, assign the truth value for L as follows. Yung first letters below example or yung nasa first box, yun yung truth value kapag true yung mga L. Next, yung nasa baba naman nun or yung second box ay yung mga possible truth value ng L kapag false siya. We can observe that the truth value in the box cannot be true and therefore, you cannot maintain the truth of the premise set while retaining the falsity of the conclusion. You may conclude that the argument is valid, but remember, there are other combinations of truth values in the conclusion considering that it is a conjunction. Notice that in the remaining combinations of the truth values of R and C, you were able to falsify the conclusion while retaining the truth of the premise set. The argument form, therefore, is invalid. According to Mr. Acuña, remember only one example of a horizontal where the premise set is true and the conclusion is false is sufficient to judge an argument form to be invalid, but not being able to succeed in doing so, so it does not necessarily mean na yung argument is valid until you have exhausted all possibilities. Lastly, if the conclusion is a single statement, it has only one possibility. If the conclusion is a disjunction or a conditional, then there is only one possible combination of truth values to make it false. However, if the conclusion is a conjunction, it has 3 combinations, and if it is a biconditional, it has 2.
That concludes our presentation on Andresito Acuña's book entitled Philosophical Analysis, Advanced Techniques for Critical Thinking, specifically Unit 3, The Analysis of Deductive Arguments, Modules 2 to 7.
We hope you learned a lot since the concept may seem unfamiliar and complex, but one must agree that it was intellectually stimulating.
Again, I am Toni.
And I am Evonne. Thank you for listening.